Sometimes when we're solving log equations, we end up with more than one term that has a log. So if you take a look at this one, outside of the parentheses, we have subtraction here. And addition and subtraction, that's what separates terms. So outside of the parentheses, here's a subtraction. So we have a log, that's one term here, and another log, and that's another term here. So we have two logs in this problem. When you have a problem that has multiple logs, the process that you should use to go through and solve should be to get all of the logs on one side of the equal sign, and anything that does not have a log in it on the other side. So this one's ready to go, but we could need to add or subtract some values on each side so that all the logs are over here on the left and anything without a log over on the right. From there, we want to condense this. We want to take these two logs and write it with a single log. That's a two-step process using some of our properties of logs. We can take a log, and if there's a coefficient in front, we would want to write that as a power. So if there was a number being multiplied here in front, I'd want to raise this 100 to that power. Same thing with this log. If there was a number here in between the subtraction and the log, I'd want to take whatever that number is and make that an exponent. In this case, we don't have to do that step. And then from there, we will take the logs that are being added or subtracted and write them with a single log. If you have subtraction, you're going to end up with a fraction. I'm going to copy that log down in front. It's log base 4. And then any log that is positive, so if you look in front of this log, there's an invisible positive 1 out in front. And since that's positive, the 100 is going to go in the top. Any log that has a negative in front of it, or a subtraction, that value is going to go in the bottom. So when you look at this log in front of it, there is a subtraction there, so this log is like a negative, which means the x plus 1, that's going to go in the bottom part of our fraction. Once you have a single log over on the left side, then you're going to exponentiate in order to get rid of the log. We have a property that says if you have a value that is raised to a power, and up in the power you have a log, and the base of your exponent and the base of your log match, these things will simplify just to that value. Basically, the two bases and the log, they will end up canceling each other out, and we just get that value, x. So in this problem, what I'd like to do is make both of these sides of our equal sign into exponents. And what I want to do is take both of them and make them exponents. So I need to write in a base here. This side will become something raised to the first power. This side will be something raised to this log base 4 power. I can choose the base here on both sides of my equal sign to be any number I want, but I'm going to choose it to be whatever the base of the log is so I can use this property. So I'm going to write the left and the right sides that we had in the previous step as exponents with a base of 4. If you take a look at the left side now, we have 4 raised to the log base 4 power of something. That's like this property here. So the 4 and the log base 4, because they have matching 4s there, that will all cancel out, and we will just end up with the left side of our equal sign here. So the value we're taking the log of, which is 100 over an x plus 1. On the right side, I do have 4 to the first power, which is just 4. As you're solving log equations, you do have to get rid of the log using exponentiation. Get a single log first, and then exponentiate both sides so that you can get rid of the log. And then from there, then we can go through and solve. So I have 100 over an x plus 1. I'm going to multiply both sides by this x plus 1 so that I can get these to cancel out. That would leave me with 100 is equal to 4 times x plus 1. If I distribute that in, I would have a 4x plus 4. Subtracting 4 on both sides gives me 96 is equal to 4x, and then dividing by 4. We end up with our solution, or at least our possible solution, which is x is equal to 24. Whenever you go through and you use this exponentiation step that we did here, you do have to go back and plug your numbers back in to check your work. So I need to check and see if 24 is actually a solution or not. Okay, so let's see. I'm going to take 24 and I'm going to plug that in for all of the x's up here at the top. There's only one spot really to plug that, so I'll plug that in there. So that would give me log base 4 of 100 minus log base 4 of 24 plus 1. I want to see if that's really equal to 1 or not. I'm going to type this into my calculator. Remember that when you type this into your calculator, if you do not have the ability to write your base in so that you can type in the 4 here, you'll need to use the change of base formula. So when I type this in here, I'm going to be typing log 100 divided by log 4. That changes this from log base 4. These are both log base 10s. There's no numeric value written here for our log, so that is log base 10. And I do have a button for that on my calculator. Now, my calculator does not have the ability to change the base when I type this in. So I'm going to type in log base 4 of 100, but I'm going to do that doing the change of base formula. So that's going to be log of 100 divided by log of 4. So there's that piece. And then we have a subtraction. I need to do the same thing here. I'm going to do log of 24 plus 1 over log of 4. You certainly can write that as log of 25 divided by log of 4, but just type it in exactly the way that it is there. So using the change of base formula, I now have the left side typed in, and it says that that does equal 1. So here's my substitution to do my check. I ended up with the left and the right sides of our equal sign matching. That definitely tells me that 24 is a solution. You do need to check your work on that. If you just go down and come up with 24 as a solution without showing this check, you wouldn't be able to get full credit on that problem. You need to check your work on all of these log problems when you're solving. Anytime that you go through and you exponentiate both sides of your equal sign, checking your work at the end is part of the problem. It's not just an additional optional step that you could do if you wanted to. You have to do that check.